Our rivers and oceans are witnessing a disturbing trend. Large numbers of fish are dying suddenly. This phenomenon is known as a fish kill or a die-off. Thousands, sometimes millions of fish wash ashore. They float lifelessly on the water surface. These events are happening more frequently across the globe. This signals a deep problem in our aquatic ecosystems. We must pay urgent attention to these warning signs from nature. The health of our waters is clearly in peril. Imagine a riverbank covered with dead fish. This was the reality in Texas in June 2024. Thousands of fish perished along the Gulf Coast. A similar tragedy struck Australia's Darling Barker River in March 2024. Millions of fish died there. These are not just numbers. They represent a massive loss of life. Understanding why these fish are dying is the first step towards finding solutions. The problem is global, affecting diverse water bodies. Each incident tells a story of an ecosystem pushed beyond its limits. The most common reason for these mass fish deaths is simple. The fish cannot breathe. They suffocate due to a lack of dissolved oxygen in the water. Quentin Grafton, an expert on water economics, has highlighted this. Fish, like us, need oxygen to live. They absorb it directly from the water through their gills. When oxygen levels drop too low, they struggle. Then they die. This lack of oxygen, known as hypoxia or anoxia, can develop rapidly. Several factors can lead to this critical condition. Sometimes native fish species die first. They are often more sensitive to low oxygen levels. Invasive species, which are often hardier, might survive longer. They can then take over the ecosystem. This further damages the natural biodiversity. A 2021 report by 16 global environmental organizations warned us. It stated that a third of freshwater fish species are threatened with extinction. Fish die-offs are making this crisis much worse. When oxygen levels fall, fish exhibit signs of distress. They may gasp at the surface. They might swim erratically. Eventually, if the oxygen does not return, they perish. Human interference with natural water flow is a major culprit. We extract vast amounts of water from rivers. This water is mainly used for agriculture. When too much water is taken, river levels drop significantly. This makes rivers unhealthy. They become more vulnerable to extreme weather events. Professor Quentin Grafton points out that this over-extraction is a key problem. The Darling Barker River in Australia is a stark example. Upstream irrigation has drastically reduced its water volume. This sets the stage for disaster when other stressors appear. Dams and weirs also play a harmful role. These structures trap fish. They prevent fish from escaping areas with poor water quality. If oxygen levels drop in one part of a river, fish naturally try to move. Dams block these escape routes. Professor Fran Sheldon, an expert in river ecology, has explained this trapping effect. Fish get stuck in these oxygen-poor zones and perish. The recent fish kill in the Darling Barker River in March 2024 was worsened by this. Floods initially caused a fish population boom. Organic matter was washed into the river. Another significant cause of fish kills is nutrient overload. This happens when too many nutrients like nitrogen and phosphorus enter water bodies. These nutrients come from various sources. Runoff containing fertilizers from farms is a major contributor. Industrial waste and untreated sewage also carry these excess nutrients. When these substances leach into rivers, lakes, and coastal waters, they trigger massive algae blooms. These blooms can sometimes be seen as thick green or brown scum on the water surface. They are a sign of an ecosystem out of balance. While algae produce oxygen during the day through photosynthesis, the problem intensifies when these blooms die. The sheer volume of dead algae provides a feast for bacteria. These bacteria then multiply rapidly. As they decompose the dead algal matter, they consume vast amounts of oxygen. This process can quickly deplete the dissolved oxygen in the water. This leads to the suffocation of fish and other aquatic life. It creates what are often called dead zones. These are areas where oxygen levels are too low to support most marine life. This is a common pathway to mass fish deaths. A tragic example occurred in mid-2024 in Poland. Section 5. Climate's fever pitch, warming waters and gasping fish. Our changing climate is making fish die-offs more frequent and severe. Rising global temperatures are warming our rivers, lakes, and oceans. Warmer water holds less dissolved oxygen. This is a fundamental law of physics. Professor James Renwick, a climate scientist, has emphasized this connection. Even a small increase in water temperature can significantly reduce oxygen availability for fish. Global sea surface temperatures have risen by about 1 degree Celsius over the last 4 decades. This might seem small, but it is a huge change for marine ecosystems. This warming affects both river and ocean fish. However, marine fish can be particularly sensitive to these temperature changes. In June 2024, thousands of fish died along the Gulf Coast of Texas. This event was directly linked to a sudden warming of the ocean. This warming depleted oxygen levels, leading to the fish kill. Similarly, in 2024, marine salmon farms in New Zealand faced a crisis. A rapid surge in water temperatures hit these farms. Operators were forced to dump over 1,000 tons of suffocated salmon. These incidents are clear evidence of climate change's impact. Rising temperatures can also trigger other harmful processes. Section 6. Invisible killers. The threat of direct chemical poisoning. Sometimes fish die not from lack of oxygen, but from direct poisoning. Toxic chemicals or other harmful substances released into water bodies can kill fish quickly. This is particularly common in areas with poor environmental safeguards. Industries may discharge untreated waste. Accidents can lead to spills of hazardous materials. These events can have devastating consequences for aquatic life. The chemicals can damage fish gills, interfere with their nervous system, or cause internal organ failure. The result is often a sudden and large-scale die-off. One such incident occurred in Madagascar in March 2024. A mining company, Rio Tinto, was permitted to release wastewater. This wastewater was contaminated with acidic effluent and aluminum. It was released into the Mandramondramotra River. Soon after, thousands of dead fish washed up in lakes connected to the river. This devastated local fishing communities who depend on these waters for their livelihood. This case highlights how industrial activities, if not properly regulated, can directly poison aquatic ecosystems. The pursuit of resources can sometimes lead to the destruction of life-sustaining environments. Another example took place in August 2019 in the United States. A steel mill in northwest Indiana released cyanide and ammonia. Section 7. Beyond the banks. Rippling impacts on nature and people. Mass fish die-offs have far-reaching consequences. They contribute to a larger biodiversity crisis. 1/3 of freshwater fish species are threatened with extinction. Fish kills exacerbate this problem. Native species are often hit the hardest. They may be less resilient to pollution or low oxygen. Declining native fish populations change entire ecosystems. Invasive species might take over, reducing biodiversity. This weakens the health of our water bodies. The impact on local communities can be devastating. Many communities depend on fishing for survival and income. Large fish die-offs mean loss of food and livelihood. The fish kill in Madagascar severely impacted local fishing communities. Similarly, the die-off in Volos, Greece, reduced commercial activity by 80%. This shows the direct economic consequences. Tourism can also be affected by dead fish and polluted waters. The ecological ripples are significant. Fish play a crucial role in aquatic food webs. Section 8. Turning the tide pathways to healthy aquatic worlds. Preventing future fish die-offs requires a fundamental shift in how we interact with our ecosystems. We need to build a more sustainable relationship with nature. Experts emphasize the need to regulate substances dumped into lakes and rivers. Limiting water extraction for agriculture is crucial. Improving irrigation efficiency and exploring water-wise farming methods is essential. Protecting our water sources from pollution and overuse is paramount. It is the first line of defense against aquatic tragedies. Improving stormwater management is also crucial. Reducing nutrient pollution from stormwater runoff can help prevent algal blooms. Creating green infrastructure in cities like rain gardens and permeable pavements is vital. Better urban planning that considers water quality is needed. Implementing best management practices in agriculture is essential. Using fertilizers precisely and creating buffer strips of vegetation along waterways can trap runoff. Every action to reduce pollutants entering our waters helps. Accelerating efforts to mitigate climate change is crucial. Reducing greenhouse gas emissions is urgent. Stopping the burning of fossil fuels is necessary. This is the only long-term solution to prevent further water warming and marine heat waves. Every fraction of a degree of warming avoided will benefit aquatic life.